Okay, let us continue solving quadratic equations by factoring with a couple more examples. And we're going to, again, invoke the zero factor property to ultimately solve these equations. That's kind of the name of the game. Factor so that you can use the zero factor property to solve the equation. So let's start with this one here on the left. I don't have a 0 on one side of the equation, so I need one. I can either put the 0 over here or on this side. It doesn't really matter. So since I only have a single term on the left side, I think I'll start there. Subtract the 4x squared from both sides. I'll just stick that over here since it's not a like term. You may prefer it the other way so that you have a positive coefficient of x squared, but again, you'll get the same result in the end, so it's okay either way. Let me put a 0 here, equals, and I'll write it in standard form, putting the x squared term first, so negative 4x squared, and then the plus 20x minus 25. I'm going to pause for a moment and see if there's a greatest common factor that I can factor out. And it does not look like there is a greatest common factor. So I can look for a perfect square trinomial, which this kind of appears to be, or I can use method 1, 2, or 3, spoken of in previous sessions. So let me, in the factoring videos, let me just do method number 3. And maybe we can highlight something interesting also about method number 3 while I'm doing this. Again, watch those factoring videos to see what method number 3 was. But you'll see it right here as an example. Negative 4 times negative 25 produces positive 100, and then I'm going to try to factor this into two things that multiply to give me 100 that also add to 20. Thank goodness, that's pretty simple in this case. 10 times 10. All right, so then that means that using method number 3, I can go straight to the solutions with these two guys, or straight to the factors. And I'm going to focus on solutions, actually. What I can say is that we have x plus 10 divided by negative 4, x plus 10 divided by negative 4. Remember, this is method number 3. Reduce these fractions so that I've got x minus 5 halves times x minus 5 halves. The fact that you get the same thing means this was a perfect square trinomial. You can see the square right here. Now, if you were to multiply these two factors right now, just to check, you would not get that original trinomial. You would have to bring these 2's up here, and then you still would not get it by a factor of negative 1. However, when it comes to solutions, if I set this equal to 0, here's one of the awesome things about method number 3. Because I already have my 0 over here, if I set these equal to 0, the solutions of this will indeed be the solutions of our original equation and the solutions of this equation right here. So from here, we're going to say x minus 5 halves is equal to 0. And I'm only going to say it once because I would just be saying the same thing again for this factor since they're identical. From here, add 5 halves to both sides. 5 over 2. 5 over 2. And that gives me x is equal to positive 5 over 2. And that's it. We can say that there indeed are two solutions to this equation, but the solutions are the same. They're both 5 halves. So we can say the solution is x equals 5 halves with duplicity 2, or just put a box around x equals 5 halves, and you'll be okay there. We should check that. So let me erase some of this right here. I'm just going to check it with the original equation, make sure we're okay. X equals 5 over 2. Okay, so I'll just keep that part right there. Apply some elbow grease to the glass in front of me. All right. There we go. I'm just going to retain that and see how it works. So here's the check. First, I'm going to check the left side. and then I'll check the right side. If they're equal to each other, I know we've done a good job. 4x squared looks like 4 times 5 halves squared, which comes out as 4 times 25 over 4, which is 25. Cancel, cancel. Okay. Now we're going to check the right side of the original equation. 20 times 5 halves minus 25. I can do a little cancellation right here. Make that a 10. 10 times 5 is 50. Minus 25 is equal to 25. Same thing on both sides means, yep, x equals to 5 halves is indeed the solution. X equal to 5 halves. Now that was kind of tricky perhaps how I used method number 3 to do that in factoring. So what I would suggest is go back and start with the same problem, 4x squared equals 20x minus 25, and try it in a couple different ways. Try it using method number 1, try it using method number 2, which involves factoring by grouping, and see if you can end up with the same solution. Okay, let's take a look at this next one. 16x cubed plus 28x squared equals 30x. I still need this 0 on one side of the equation or the other. So I'm going to start by getting rid of this 30x over here. It doesn't add with any of these things, so I'm just going to put it off to the side just to remind myself it is not a like term. On the left side, I'm going to rewrite this in standard form. It's pretty close. 16x cubed plus 28x squared, and then I'll put my minus 30x is equal to 0. Whenever I have numbers that appear larger than 10, I like to see if there is a greatest common factor. Moreover, I see that I have an x cubed, an x squared, and an x. So there is a greatest common factor. If anything, the greatest common factor is just x, because it shows up as a factor in every term. But there's more than that. Maybe a 4. Well, no. Let's try 2. So we'll take out a 2x. And see what we're left with. That gives me 8x squared here, plus 14x from that term, minus 15, and all of that is equal to 0. Now, I can use a zero factor property immediately, and then maybe another one a little bit further down the road, and the first instance would be to say that 2x equals 0, or 8x squared plus 14x minus 15 equals 0. From the left side, 2x equals 0, from the left equation I should say, divide both sides by 2, and we can see that x equal to 0 is one of the solutions. Now you could have guessed that immediately because when we had this equation equal to 0, you see this x showing up everywhere, so clearly if you put a 0 in for x, 0 squared, 0 cubed, all of these things would give you 0, and you end up with 0 in the end. I think that's also called the trivial solution to this problem. But watch that word trivial. Some people will say it's trivial, and it's really hard, so we'll be careful with that. Okay, so this remaining trinomial equal to 0, how can I solve this? Well, you're going to try method 1, 2, or 3 to factor this thing. How about method 1? We'll just go with a different one. Method 1 explores the factors of the leading coefficient and the constant term. So for example, I could have 1 times negative 15, or negative 1 times positive 15, 3 times negative 5, or negative 3 times positive 5. These are all factors of negative 15. And I've also got to look at 8, which could be 1 times 8, 2 times 4, and I don't need to explore the negatives because I've already done it over here. Now remember, I'm going to try to come up with a sum of products that gives me 14 in the middle. So for example, 1 times 1 plus 8 times negative 15, that's pretty far off. Let's try somewhere in the middle. How about the 2 and the 4 and the 3 and the negative 5? So something like 6 minus 20. 6 minus 20 is negative 14, so that was pretty close. Maybe it's these two in the same order. Negative 6 plus 20. Okay, that's it. Using method number 1, I'm going to take advantage of these two guys in this order to say that 2 times negative 3 plus 4 times 5 gives me negative 6 plus 20, which is indeed 14. That's what I was looking for this 14 right there. That means that this thing, this trinomial, factors into 2x plus 5 times 4x minus 3. And now I can say, since that trinomial was equal to 0, this must also be equal to 0. Then I can use a zero factor property. Let's see, am I on the screen over here? I just want to make sure that that's showing up. I think it's pretty close. Yeah, it looks like we're okay. Okay, so let's move on to the zero product principle here with 2x plus 5 equal to 0, or 4x minus 3 equal to 0. Let me just do that independently since I'm running out of space. I will subtract 5 from both sides here. That gives me 2x equals negative 5. One more step. Divide both sides by 2, and I get one of the solutions, x equals negative 5 over 2. And 4x minus 3 is equal to 0 is the last thing we have to solve. 4x minus 3 is equal to 0, so I'm going to add 3, running out of space. Okay, there we go. And we have ourselves a final solution here of, oh, do I have space? X equals 3/4. So we've got x equals 3/4, we've got x equals negative 5/2, and don't forget about this guy that we started with, x equals 0. So if I want to check these things, I have to check each one of them independently in the original equation, and just one at a time. First the 0, that's clear, and that checks out immediately. Then the negative 5/2, cube it here, square it here, put it in over on the other side. The left side must equal the right side. And I leave that to you to check on your own time. And now we're going to move on to a few more examples and then applications.